EDX Decision 1, Graphs and Networks 1, Definitions and Spanning Trees. Finding the minimum spanning tree using Prim's algorithm in a table form. Prim's is an example of a greedy algorithm in that it maximizes immediate rewards without considering future consequences. We've already seen how it works when we have a graph of a network. This is the most useful form for computers. What happens when the network is given in a matrix or table form? We could reconstruct the graph from the table, but this is generally inefficient, especially for large networks. So here we have our tabulated form of the network with nodes A, B, C, D, E. We choose a starting node, we number the column 1 and delete that row. We look down all the numbered columns to find the smallest value that is not crossed out and circle it to show that it is now being selected. Take the node corresponding to the entry you have just selected, label its column with the next number and delete its row. Repeat steps 2 and 3 until all the rows are used up. The starting node may be given in the question. Crossing out a row shows that the node has already been connected. And always list the edges in the order that you have selected them. So I'm going to start by selecting node A, so that's my first node, which means I can cross out row A because A is now part of my solution. But the other thing I often do is I just highlight the column. It just serves as a reminder that A is in my solution. You don't have to do this, but it might help you to spot what's going on. So I now look for the shortest edge that I can connect to A, which is this 1. So I've now connected A to E, that's 1 unit. E is the second node in my solution, so I cross out row E because we don't need to connect it to the solution more than once, and I'm going to pick out that column just to make the method stand out. So I now look at both column A and column E, looking for the nearest neighbour, and the nearest neighbour is going to be this 1 here. That's the next shortest edge I can connect to A or E. So I've now connected E to F at 1 unit. I can cross out row F since it's part of the solution. F is my third node to be connected, so I can just pick out the column so that F is clearly part of the answer. And now I look at column A, E and F, looking for the nearest neighbour. The shortest edge is going to be either that 2 or this 2, and I'm going to choose this 2. So I've decided to connect E to D. I get a choice there of 2s. So D is part of the solution. It's the 4th node in my solution, so I'm just going to pick out that column. And now I look for the next shortest edge in A, connected to A or D or E or F, and the next shortest edge to use is this 1. So I'm connecting C to D at 1. So C is part of the solution, so I can cross out row C. C is the 5th node to be connected to the solution. So again, just picking out the column. So now I look at column A, C, D, E, F, looking for the next shortest edge to use, and it's this 2 here. So that's B to C, 2 units. B is now connected to the solution, so I can cross out row B, and it's the 6th node to be connected. and I can stop now because I've repeated steps 2 and 3 until all the rows have been used and crossed out. So I can stop there, and my minimum spanning tree is the total, and the total is 7 units. And there is just a neater version. You don't have to do the highlighting the columns, you can just number them in the order that you select them, if preferred. Some of the common errors with prim in tabular form: not starting at the specific vertex when requested in the question, not deleting a row, so possibly forming a cycle accidentally. Remember, the correct use of Prim's algorithm should never produce a cycle. Not checking all available columns, and that will miss a shorter arc. Forgetting to record the order of the arcs as you go along. And forgetting to state the length and weight of the minimum spanning tree as the final answer. In the next session, we'll be looking at minimum spanning trees using Kruskal's algorithm.